Hello everyone, I am Naveen Kumar from EC department. Let's see about the error control mechanism. Error control mechanism. It involves two possible ways, error detection and error correction. In error detection, let's see three types: parity check, cyclic redundancy check, checksums. Let's see about the basics. We all know what is the error. Error is some mistakes. In networking, error is a condition when the receiver's information does not match the sender's information. The receiver information is zeros or 1 either, but the sender's information does not match. In error, there is three types in bits: single bit error, multiple bit error, and burst error. Single bit error. In a frame, there is only one bit anywhere though which is corrupted. Let's see the example in this frame. The sender message is 1 0 1 1 0 0 1 1, but the receiver get is 1 0 1 1 0 1 1 1. There is one error. The zeros was changed into 1. This is the corrupted. It's a single bit error. In multiple bit error, a frame is received with more than one bit in corrupted state. Let's see the frame. The 1 is changes 0 and the 0 is changes 1, and this is the multiple bit error. Burst error. Frame contains more than one consecutive bit corrupted. The sender message there is 3 consecutive error. Let's see. 0 1 1 is changed into 1 0 0. The consecutive error is called as the burst error. Parity check. In a parity check, there is two conditions: even parity check and odd parity check. In a even parity check, to count the ones bit in a binary data, if it is even, then zeros is to be added. It is odd, ones to be added. Let's see the example. There is 1, 2, 3 and the 3 ones. Then added a 1. In this 1, 2, 3, 4. There is 4 ones. Then it is even, so add 0. Now add parity. To count the ones bit in binary data, if it is even, then add the value is 1. Suppose it is odd, the zeros is to be added. There is 3 1, so 0 is to be added. And this there is 4 1, it's even, so 1 is to be added. So it is the add parity. Now see about the cyclic redundancy check. It's CRC. CRC is the different approach to detect if the received frame contains valid data. This technique involves binary division of the data bits being sent. The divisor is generated using polynomials. The sender performs a division operations on the bits being sent and calculate the remainder. Before sending the actual bits, the sender adds the remainder and the end of the actual bits. Actual data bit plus the remainder is called code word. Let's see the example. The sender message is the divisor is 101 and the division is 11001. After simplify, the remainder is 10. It is the CRC. The receiver gets the message after adding it 1100110 is the division. After simplify, the remainder is 0. There is no error. Now let's see about the error correction. The error correction codes are used to detect and correct the errors when the data is transmitted from the sender to the receiver. It is two types: backward error correction and forward error correction. In backward error correction, once the error is discovered or detected, the receiver requested to the sender retransmit the entire data unit. In forward error correction, in this case, the receiver uses the error correcting code which automatically recorrect the error. Now see about the black coding. It is the type of forward error correction. The black coding is the method used in the digital electronics to encode the data into a specific format. The purpose of black coding is to add redundant information to the data, which can be used to detect and correct errors that may occur during transmission or storage. It is applied before line coding. It replaces each m bits block with n bits block. It requires three steps. The first step is division, then substitution, then combination. Let's see about the blocking code. The binary data is there is the binary data. The m bit division, it was the first division step. A sequence of bit is divided into a group of m bit. After its division steps, the substituting step, we substitute the m bit group for a n bit group, and then finally n bit group are combined together to form a stream, and then it performs the line coding. Now let's see about the checksums. The definition of the checksum. The checksum error detection is a method used to identify errors in the transmitted data. The process is involved dividing the data into equally sized segments and using a ones complement to calculate the sum of these segments. Then calculated the sum is then sent along with the data to the receiver. At the receiver's end, the same process is repeated, and if all zeros are obtained in the sum, it means that the data is correct. Let's see the checksum operation at sender side. Firstly, the data is divided into k segment, each of m bit. Let's consider k and m. On the sender's end, the segments are ordered using ones complement arithmetic to get the sum. The sum is complemented to get the checksum. The checksum segment is sent along with the data segment. The checksum operation at receiver side. After at the receiver ends, all received segments are added using ones complement arithmetic to get the sum. The sum is complemented. After complemented, if the result is 0, the received data is accepted if the result is 0, otherwise discarded. Let's see the example. Let's consider k equal to 4. There is the 4 binary input data. The sender add the 4 binary input data. If the adding data there is any carries, added it again. After adding the 4 k bit times, like in this example the k equal to 4. After adding all, the sum equal to 0 0 1 0 0 1 0 1. Let's check sums. After complement it, 1 1 0 1 1 0 1 0. The same process in the receiver side. After get all values, the sum is all is 1. After complement is 0. So it is the accepted data. Linear block coding. It is a simple error control coding technique used for the error correction. Data information is divided into a blocks of length of k bit, that is data word. Now each data word is then coded into a block of length n bit, that is code word. The condition is satisfied where n is greater than k. N equal to k plus r. The r is the parity bit or check bit is ordered to each data word. The vector notation is used for data word and code word. For data word, let's consider m is equal to m1, m2 up to mk. For code word, it's considered as u, u1, u2 up to un. Let's consider the block diagram of linear block code. Message K into channel encoder, a coded message here. Thus, we have 2 power k is distinct message blocks and 2 power n is distinct code word. There is always one unique code word for each data word. The code rate is equal to k by n. Types of block coding. There are several types, some included. Hamming coding. It is the type of block code that can detect the single bit error. Reed-Solomon code is the type of block code that can detect multiple bit errors. And PCH code. This is the type of block code. It can correct a specific number of errors. Now, see about the cyclic code. A cyclic code where the circular shift of each code word gives another word that belongs to the code. They are error coding codes that have algebraic properties that are convenient for efficient error detection and correction. Let C be a linear code over a finite field of block length n. C is called the cyclic code. If for every C word, code word is C, C1 up to Cn, from C, the word Cn, C1 up to Cn minus 1. The Cn last term is comes up to first term. Is obtained by a cyclic right shift of component is again a code word, because one cyclic code may also be defined cyclic left shift. The linear code C is cyclic precisely when it is invariant under all cyclic shift. Let's see the example. The binary bit is 0 0 0 1 0 1 1 1 is MSB to LSB. The last term is 1 is come up to first term. Then after all term is rearranged. If the initial term is valid code word, applying the right circular shift gives the string. After shift is also a valid code word. In generally, applying the right circular shift move the least significant bit is LSB to the leftmost bit position so that it becomes MSB. The other position are shifted by 1 to the right. And finally, let's see about the application advantages and disadvantages of the error control mechanism. There are many applications like data communications, voice and video streaming, file transfer, remote access and sensor networking. In advantages, there are data integrity, reliable communication, efficient data transfer, improved user experience and reduced bandwidth wastage. In some advantages and disadvantages, it is a overhead and very complexity and some latency, not always necessary, limited error corrections. Thank you for the opportunities.